Okay. The next rule is called the product rule. The name's nice. Product. It's referring to multiplication of two functions. So if you have a function that you can break it down into a multiplication of two other functions, the derivative goes like this. You differentiate g and you multiply by h. Don't differentiate h. Plus, you differentiate the h and multiply by g. So alternate. Alright, so let's do a quick proof. So let's say I want to differentiate the derivative of f at x, right, which is, again, this is how you start. That's the definition. You always start from the definition. Let's replace the f with this. Okay, so I plugged it in, but we really need to get to here. If I were to write this in the first principle, right? Here's how it's going to look like. So this is actually a short form of this, what I have written here. This is a definition of g prime at x times by h at x, g at x times by h prime at x. Okay, so we can turn this, or we would like to turn it into that. Okay, let's just think about how would I get this from what I have here. So I need gx plus h minus g at x. I have that, but I got something else attached to it. So the only way to really get rid of it is to factor that out. To do that, I need another term with h at x plus h. Right? So guess what I'm going to do? I'm going to add it in. So I can factor it out. When I factor it out, I need this exact thing up here. Gx plus h minus g at x. So this should have a g at x attached to it. But am I allowed to do this? Just add it in?
No.
When you add something in, what do you have to do right after? Good. Good.
Where's h at x?
All over h. Actually, you know what? This all over h, let's break it. So it's these two guys over h and these two guys over h. Alright. Factor out what we wanted to factor out, which is h at x plus h. Then we get g at x plus h minus... Oh, I need minus, right? I need minus. I have a plus here, so I should actually group that one with this. Okay, then I get minus. Okay, here I have to group this one here with this one. What do they have in common? Good. Right. Then we have h x plus h minus h at x all over h. Take a look. Compare that with what we're going to get to. Do you see that this is a derivative of g at x? Do you see that's a derivative of h at x? We have it. h at x times by g prime at x, g at x times by h prime at x. That's the proof. I made a mistake here. Do you see I grouped these two?
Yeah.
So these two, there should be a plus here. So plus here. So that's the proof, right? There shouldn't be a minus there.